In this lesson, we're going to work on arithmetic sequences. So now we want to find what is the difference between an arithmetic sequence and a geometric sequence. So an arithmetic sequence is also a sequence of numbers, but this time it has a common difference. So getting from one number to another, either we're adding or subtracting. So let's start with these examples. If I go 3, 7, 11, it looks like we're adding 4 each time. So that's going to be our difference. Our common difference is going to be 4. So to add 4, 11 plus 4 would be 15, and 15 plus 4 would be 19. So our first term in this sequence, a sub 1, would be 3. But something that we're going to need when we write our rule is to come up with the term that is before the 3, and we call that our a sub 0 term. So instead of adding 4, we're going to subtract 4 from 3, and our 0 term would be negative 1. In the next example, our sequence is going down, so we're actually subtracting 5. So that means our difference is negative 5. Our first term is 8. So we subtract 5 each time. 8 minus 5 is 3. 3 minus 5 is negative 2. Negative 2 minus 5 is negative 7. Negative 7 minus 5 is negative 12. And if I want to go to the term before, which we call our 0 term, instead of subtracting 5, I'm going to add 5 when I go backwards. So my 0 term would be at 13. Okay, so now what we need to do is decide if this is an arithmetic sequence or not. So when we look at these, if you go from negative 10 to negative 6, that would be adding 4. When we go from negative 6 to negative 2, that would be adding 4. But when we go from negative 2 to 0, that's going to be adding 2. So that changed. So this one would be neither, because we are not multiplying and we're not adding the same amount each time. In this sequence, I'm adding 6, and it looks like it's happening each time for the numbers that we have listed. So that pattern, our difference is 6. And it means that, yes, this is an arithmetic sequence. So arithmetic adding. The rule for the arithmetic sequence is that we take the difference times whatever term we're on, which is n, plus the a sub 0 term. So writing a rule for this sequence, we know that going from 32 to 47, that we're adding 15. From 47 to 62, we're adding 15. From 62 to 77, we're adding 15. So we know that our difference is 15. And in order to write our rule, we have to come up with our 0 term. In other words, what would happen before 32? So since we're adding 15 each time, we're going to subtract 15 to go backwards. So our 0 term is going to be 17. So to write our rule, we say a sub n equals 15 times whatever term we're looking for, plus our 0 term, which is 17. Now the reason we need to use the 0 term is because if I were looking for the first term, I would want to put a 1 in here, and that would give me 15 times 1 is 15 plus 17 is 32. That will give me my first term, which is 32. If I didn't go backwards and I put a 1 in, it would actually give me the term afterwards. So now we want to find the 12th term. So a sub 12 equals 15, substitute in the number 12, and then add 17. So 15 times 12 plus 17 is 197. Okay, let's practice a couple more of these. So here's our sequence, And it looks like we are going down by 5 each time. So our difference is going to be -5, and that's how we put subtraction in. And then if we want to go backwards to find the a sub 0 term, instead of subtracting 5, we're going to add 5. So my 0 term is going to be 35. So a sub n is equal to -5 times whatever number term I want to find plus 35. So if I want my 10th term, a sub 10, is going to equal -5 times 10 plus 35. -5 times 10 is -50, and -50 plus 35 is equal to -15. And that's finding that one. Okay? So now what happens if they give us other information? So if one of the terms in our sequence, our 8th term, is 50, and we know that the common difference is 0.25, we want to write the rule. So the first thing that we're going to do is we're going to look at what the form of the rule is. So remember that a sub 8, so we're going to use n equal to 8, and we're going to use this 50 as our answer to the problem. So we're going to plug in what we know. We know that the answer is 50. We know that the difference, 0.25. We know that our n is 8, but we don't know what our 0 term is. So all we have to do is the math. So 50 is equal to 0.25 times 8 is 2. And if we subtract 2 from both sides, our 0 term would be 48. So now we can write the rule. So a sub n equals our difference, which is 0.25 times n plus our 0 term, which is 48. And that would be the rule given other information. Okay, similar problem. We know that a sub 5 is equal to 30. So we do know that that 5 is our n, the number of the term. 30 after the equal sign is going to be our answer in our rule. And the difference, d, is equal to 4. So we're going to plug that information into our rule so that we can find our 0 term to write our rule. So our answer, which is 30, equals our difference, which is 4, times 5, which is our number, and that will help us to find our 0 term. 4 times 5 is 20, and if I subtract 20 from both sides, we know that 30 minus 20 is 10, is going to be our 0 term. So now we can write our rule. A sub n equals the difference times the n, the number of the term that we want, plus our 0 term, which is 10. So what if we are given 2 terms and we want to write the rule? Okay, so what we're going to do is very similar to what we've done before. This is our n, and this is our answer. So we're going to start by filling in our formula with what we know. So our answer is 10. And we don't know the difference right now, but we do know that n is 5, and we don't know our 0 term. So what we're going to do is we're going to solve for a sub 0. So we're going to subtract 5d from both sides. So we have 10 minus 5d is equal to a sub 0. And I'm going to put a box around this because we're going to use it again in just a minute. Now we're going to do the same thing with this point or rule, part of our rule. We know that n is 30, and we know that 110 is our answer. So we're going to start all over with our formula. We're going to put 110 as the answer. We don't know the difference, but we know that it's number 30, n is 30, and we don't know our a sub 0. What we're going to do now is take what we already solved, and we're putting it right in here for our a sub 0. So we have 110 equals 30d plus, instead of a sub 0, we're going to put 10 minus 5d. And now we're going to solve. 30d minus 5d is 25d. We're going to subtract 10 from both sides. So we have 100 is equal to 25d. And now we're going to divide by 25. And d then is equal to 4. Now we plug that number, the 4, back in here so we can find out what our a is. So we have 10 minus 5 times 4 equals a sub 0. 10 minus 20. And so negative 10 is our 0 term. So now we can write our rule. So a sub n equals, d is 4, times n, and then plus a negative or minus 10, which is our 0 term. Lastly, it says, then write the value of n for which a sub n equals negative 2. We're just going to cross that one off. That would just be a brand new problem. Okay? All right. So that is our arithmetic sequences.